Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we'd like to thank you for attending today's webinar, How Enercon Plasma Treater Customers Improve Inkjet Printing Results. Please note that this webinar is being recorded, and you will be able to access both the recording and presentation slides once they are available online, which should be within a day or two. If you have any questions during the webinar, please use the GoToWebinar question tool. We will reserve time at the end of the webinar to answer as many questions as we can. Today we are pleased to bring you insights from two industry professionals currently using plasma treating to improve their inkjet operations. Dwayne Chrest is Production Manager of Best Formulations, and Jerry Jordan is the Manufacturing Manager at WAGO. Also on our panel today is Enercon's Ryan Schilke. As Vice President of Sales for Enercon, Ryan leads a team of knowledgeable surface treating application specialists. His passion for innovation and customer success is a driving force behind Enercon's plasma and flame surface treating solutions. Today's presentation will begin with Ryan reviewing the basics of atmospheric plasma, and then we'll look at the real-world production line experiences of Jerry and Dwayne and their specific applications. Ryan will now take us through the basics of atmospheric plasma surface treating.
Thanks, Mark. Let's begin by talking about surface preparation and adhesion dynamics. We're going to dive into the specifics of both of these topics. One of the most important things that we look at when we talk about the dynamics of adhesion is, first of all, going to be the material type of which your product uses. Whether it's polypropylene, polyethylene, PET, nylon, whatever it might be, we have to take a look at that material to make sure we know what the best technology might be to match to your application. We're also going to consider the surface energy of both the substrate and the ink coating or adhesive that you're using in the process. We're additionally going to look at the surface roughness, the chemistry on the surface, the chemistry of the adhesive that you're using, and any bond stresses that may be present that once assembled that your product goes through. So as we talk about adhesion, what I like to try to tend to do is relate this to something that most people can experience in their life day to day, and that's the fact of what happens when you wash and wax your car. Before you go in and wash and wax the car, what you'll see is that the water tends to kind of wet out or flatten out over the surface of the car, but once you go through and wax your car, what happens is that water starts to bead up, and it will roll off your car easily. So what we're actually looking for in surfaces that we're trying to bond something to is we're actually looking for things to wet out or lay down. We're looking for the force of adhesion, that is the property of unlike molecules to attract, to be there. We actually don't want that beating up that you see when your car is waxed. That's the forces of cohesion in effect. So what kind of challenges do we face when we look at surfaces? This is a great illustration. I think people tend to smile when they see it. And generally, when we look at a plastic surface, it inherently has a low surface energy. And that can result from a number of things. Number one, you can have surface contamination. It could be dust on the surface, dirt, whatever it might be, depending how long from manufacturing the part originally to actually being printed or bonded, whatever process you're going through. At the same time, additives will migrate to the surface at different rates. So if you're going through and treating your surface and then printing right after something is, say, extruded or molded, you might not have as many additives that migrate to the surface. But if it sits around a while, you're certain that those will indeed migrate. Inevitably, there's going to be a limited number of bonding sites on that surface as well. All of these things tend to lead to a surface that is hydrophobic, or one, again, using that car wash example, that water, that droplet is going to beat up on your surface. So when you look at preparing your surface, you've got a number of options that you can look at. Each of them have pros and cons. The first that we'll talk about are liquid primers. You can prime the surface in any number of ways. Many times it will be an alcohol wipe, some sort of wipe on the surface. You can obviously think about the limitations here. Typically, if you're using a wipe, there's probably human involvement. So you've got someone handling a potentially hazardous material. It also tends, when you use alcohol or some sort of wipe, they tend to evaporate off pretty quickly as well. You can then automate these things a little bit and think about a mechanical preparation. You might be roughening the surface. In that case, again, you're processing a little bit faster, but sometimes what you're going to see is that now you've got wear parts that you need to replace when you're mechanically roughening a surface. You're introducing a dust into the process as well, probably something that you then need to clear off. When you get into certain applications, different than a little bit what we'll talk about today, you may also damage the integrity of the part that's being prepped as well. Vacuum plasmas offer a great solution in many cases in that you can put them on a tray and batch process them. The problem with this, while you're getting treatment around the entire object, is that it tends to be pretty slow. And for those processes that you want to run inline at any sort of rate in a manufacturing environment, it just doesn't tend to be a good solution. That's where we tend to talk about atmospheric plasma and flame treating. These can be integrated directly into your process, whether it's stationary, robotic, whatever it might be. They tend to be very economical. You need very little maintenance as well. So let's talk a little bit more about these technologies and how they tend to promote adhesion. So one of the first questions we get is, what is plasma? Folks are always asking, what is plasma? And I simply tell folks, it ultimately is an ionized gas. What we're doing is we're ionizing a gas in a couple of different ways, and we'll talk about those technologies here in the coming slides. So the first technology I want to introduce you to is what's known as blown ion plasma. You'll see that on the left-hand picture, and essentially what we're doing here on the extrusion that we show treating is we're bombarding that surface with ionized air coming out. So essentially bombarding that with a plasma. This technology is very good for very precise applications, small treatment areas, and is very versatile, being able to be used on both conductive and non-conductive materials. The center image that you see is an example of a blown arc plasma. This is going to be a bit wider of a treatment area, but tends to run at a bit slower speeds than blown ion does, and is great for a product where you might be running a little bit slower, easier to treat surfaces, and this can only be used on non-conductive materials. What you're seeing blowing out of this is actually a high voltage electrical discharge, so the ionized air does have a charge to it, and thus you cannot treat a metal or conductive object. What we round out our technology with, in addition to these blown ion, blown arc plasma treating systems, are flame treating systems. And this is exactly as it sounds. We're creating a plasma with either natural gas or propane in a flame form. And this tends to be a very flexible technology. We're able to treat both narrow and wide ranges. We're able to treat at high speeds, both stationary and robotic. You can use any of these technologies in both a stationary or robotic fashion as well. So when we use any of these technologies, what we're ultimately doing is three things. We're cleaning the surface. We talked about earlier contaminants on the surface. We're etching the surface, and more specifically, we're micro-etching the surface. As you look at anything that's gone through a plasma treating process, what you should see with the naked eye is very little change. You blow that up under a microscope, you're going to see very different. You're going to see a much rougher surface than what you began with. We're also going to lay a functional coating onto the surface as well in some cases. So just as a quick review, we looked at this image earlier. Many plastic surfaces inherently have a low surface energy, can have a contaminated surface, additives which migrate up into the surface of the product, and again, a limited number of bonding sites in which your ink coating or adhesive can bond to. All of those lead to a hydrophobic surface, or one that is going to resist whatever you're trying to stick to that, that material that you're processing. After plasma treating, this is what I kind of call the happier slide, the fun slide. We've got a higher surface energy, almost wants to dance around a little bit. We've eliminated, in many cases, any surface contamination that has occurred. We've removed migrating additives from the surface. If you do leave a treated surface there for a while, those additives can migrate up. So what we do recommend is that you're going to treat immediately prior to whatever application you're providing after. And we've increased the number of bonding sites by etching that surface, by micro-etching that surface. Ultimately, we end up with a hydrophilic surface, again, where we want to wet out, whether it's your ink, a coating, an adhesive, whatever it might be. That's going to lay down flat and want to adhere to the surface much more strongly than it did on an untreated surface. This is a great image which illustrates that car wash example. The untreated surface, or the waxed car idea, is that that beads up. And what we're really looking for is that ink coating or adhesive to lay down flat or wet out on the surface. And you see that in the bottom image here, which illustrates what happens after you plasma treat your product.
All right, thank you, Ryan, for the overview of what plasma treating does to a surface. So next, we'll take a look at how WAGO is using plasma treating to improve their inkjet printing operations. We'd like to thank Jerry Jordan for spending his time with us today. Jerry served over 20 years in the United States Navy as an aviation electronics technician. He received basic and advanced training in electronics, served as an instructor of electronics, and was deployed 5 times on 3 ships to various parts of the world and directed the daily maintenance of 13 SH-60B helicopters. As a production manager for a Midwest company, he directed the design and development of electronic demonstration and trade show electronic assemblies. He also managed the development of sewer inspection video equipment, including camera systems that are deployed by hand, water jet, and motorized vehicle propelled. Currently, Jerry's the manufacturing manager for the WAGO USA manufacturing facility in Germantown, Wisconsin. There, he oversees the daily operations of the manufacturing of custom and standard electronic and electrical assemblies, including PCBs, DIN rail assemblies, custom enclosures, and custom printed electrical connection devices. Jerry, can you tell our audience a little bit more about WAGO and the products you manufacture?
Certainly. WAGO is the innovator of spring pressure connection technology. WAGO has decades of experience in the field. Intensive research, countless analysis, and feedback from thousands of satisfied users throughout the world has provided us with a database of immeasurable wealth. WAGO uses this data as the basis for developing in-house quality standards that far surpass those required by outside agencies. Only when our products have passed numerous tests and examinations and thus have met our stringent quality demands do we deem them as good enough for our customers. It is the mission of WAGO Corporation to satisfy its customers' needs by supplying quality products on time through its most valuable resource, its people and innovation. To help achieve this mission, WAGO is certified in the United States to ISO 9001-2008. In 1951, WAGO received its first patent for electrical interconnection devices using spring clamp technology. In 1977, we released the cage clamp. In 1995, we released our first I/O products. We now offer terminal blocks, lighting connectors, custom electronic interface, controls, power supplies, and PLC products. We have 150 engineers, sales, and product support professionals here in the United States, along with 6,300 innovative minds working at WAGO worldwide and operating in over 80 countries.
Thank you for that, Jerry. And you know, you talked about quality and efficiency, and the specific project we're going to look at today involves inkjet printing on nylon 66 terminal blocks. Jerry, could you describe your process before you were using plasma treatment for printing?
Certainly. As you can see in the picture above and to the right, the connector has been custom printed in our Germantown plant. Prior to implementation of plasma, we would have had to hand wipe each part prior to running it through our inkjet printer. This wiping involved the use of methyl ethyl ketone, a very strong chemical that requires the use of personal protective equipment. We custom print thousands of electrical connection devices every day, similar to the one above. And at just 5 or 10 seconds apiece for wiping, it was very costly, and it exposed my personnel to those harsh chemicals. We were required to have custom fume extraction systems in place to remove the harmful chemical fumes from the production area. This required constant maintenance to replace the filters that would become contaminated and require hazardous disposal. Sometimes an operator's gloves would become contaminated and transfer dirt and debris to the products to be printed, resulting in scrapping of products. WAGO prides itself on producing the highest quality products, and this process was costly to both our time and our material costs.
So how did you learn about atmospheric plasma, and how did you go about testing it to see if it would work for your operation?
Back in 2012, I was making a visit to our parent company in Minden, Germany. While touring their production area that produced similar items that were printed, I saw that they had in place some special preparation equipment that virtually eliminated the need to hand wipe the parts prior to printing. I talked with my colleague who explained that the process they had in place involved the use of plasma to pre-treat the parts prior to printing. When I returned to Germantown, Wisconsin, I began to search the internet for options to perform plasma treatment of our parts prior to printing here in the U.S. I found several vendors of equipment that, I found several vendors of the equipment and found that the people at Enercon seemed to have the best understanding of my needs and the correct equipment for my application. I was able to set up an in-person meeting with someone from the company, and it was a very short order that I knew I was going to be with the right company. I made a follow-up visit to the factory and worked in the test lab with some of the people that obviously had far greater knowledge of the way plasma could work to make our life at WAGO better than anything I could find on the internet. They explained how plasma would prepare the surface to better accept the ink that we use to print our parts. They treated some parts for me, and I returned to our plant to test print them. I was amazed at how well the ink adhered to those parts. We performed our standard tape test and found 100% adhesion of the ink. We then performed thermal and chemical testing of the printing, and the results were better than our former method using methyl ethyl ketone and wiping those parts.
Excellent results. On the next few slides, we're going to share some short video clips of the treating and printing operation at WAGO. This is a new feature our GoToWebinar hosting program offers. When we play the video, the screen sharing of the presentation will stop, and a video window should show on your screen. As this is a beta feature, we'd like your feedback through the chat window on how the video played for you. Let us know if you saw the video as expected and if it played well for you. We're going to share the first clip now in one moment. Okay, the video should be playing now, and Jerry, looks like we're looking at one of your employees putting the pieces on a conveyor belt.
That's correct. Every part has to run through this printer that needs the custom printing on it. So every part had to go on the conveyor belt regardless. When we added the plasma, we removed the need to hand wipe, so you can see that that I could get a true 5 or 10 seconds per piece savings of time utilizing the plasma.
So that was moved it into a much faster continuous process.
Correct.
The operator no longer had to wipe a component before presenting it to the print head.
Correct.
You talked about some different tests that, I'm sure we're showing the screen again here. You talked about some different tests that you did, and one of the tests we captured both a short video and images of was the tape test. Can you talk about that?
Correct. Our tape test is the method that we use to do a quick check on randomly printed terminal blocks. Simply, an operator can take a piece of clear tape and place it over the printed area. They then rub the tape to ensure that they have good contact of the adhesive to the part and the printing. They then remove the tape and look at it against a white background to see if any of the ink is removed from the terminal blocks. Our plasma equipment is in line on the conveyor, and as a result, it doesn't need to have that extra time, and it properly prepares the surface for us. As a result, when we do the tape test, we pretty much get 100% accuracy once the nozzle is properly adjusted to the area.
And we've got a brief video of the tape test, which we'll attempt to play now. And I believe the video is playing now. We lost it for a second here. And what have the results been in terms of, how often do you go through a quality control process to test the,
Turn the screen back on.
Sure. How often do you go through a quality control to do a tape test or other methods now that you've kind of proven the application?
We do a tape test on the first piece that runs through whenever we set the machine up. So every order does get the tape test. And depending on the size of the order, we may do additional tape tests partway through, just to verify that everything is still functioning properly. The difference now is that once the machine is set up and running, we get great results every time. You can see in the picture on the left-hand side there where the tape test shows the ink removed from the part down below. The physical part is the tape. That was a result that we would see when we were hand wiping, because you can't guarantee that the operators are going to touch each and every part properly when hand wiping.
Got it. We'll go to the next slide here. And just as a wrap-up, Jerry, could you comment on your overall experience on what it's meant to your production efficiencies and quality and adapting plasma treating to your lines?
Well, at WAGO we pride ourselves on producing and delivering only the highest quality products. As a result, I spend a good deal of time researching any new product or process or equipment for use in our production department. Enercon took the time to ensure that I fully understood the process and how it could help in our production department. When I purchased the new equipment, I asked myself two major questions. How will this improve our process, and what are the costs involved? Plasma ensures that every part is properly prepared prior to printing. This preparation results in better printing adhesion to our terminal blocks and our assemblies. Having used this equipment for 4 years on all 3 of my printing lines, I've had the following repair and maintenance costs. I needed to replace one nozzle element that cost about $300. No other maintenance costs have been associated with this equipment. We have now placed our dynamite plasma equipment on a 4-year maintenance schedule to perform a 10-minute inspection of the nozzle assembly. Any equipment that can be placed on a 4-year maintenance schedule is a joy to have in the production department. Most of my other equipment is either on a 1-week up to maybe a 6-month maintenance schedule. If I ever need to add any additional printing stations, they will, without a doubt, have plasma treatment put in place. From the start, this equipment is easy to use and maintain. The results are outstanding and consistent with uninterrupted use.
Well, Jerry, thank you for sharing that with our audience. We're going to take a look now at Dwayne Chrest and Best Formulations' use of plasma treating in their operation. As production manager for Best Formulations, Dwayne works closely with the packaging department and cross-functional teams to ensure CGMP manufacturing and packaging of all dietary supplements into various packaging formats, including soft gel, HSC, tablets, powders, and liquids. Dwayne has extensive experience in tablet and hard shell manufacturing, powder filling, and pill packaging. Dwayne also leads the safety and sanitation activities for the organization. Best Formulation itself is a diversified nutraceutical and pharmaceutical company headquartered in City of Industry, California, and is a contract manufacturer and private labeler of thousands of branded high-quality nutritional supplements, including, again, soft gels, tablets, capsules, powders, teas, and drugs. Dwayne has worked in the dietary supplement industry for 10 years with other contract manufacturers and packagers in Southern California in operations management and plant manager roles. Previous to this, Dwayne worked as plant manager and internal consultant for Smurfit Stone across North America in the corrugated paper industry, and Dwayne received his bachelor's degree from the University of Manitoba in Canada. So Dwayne, could you begin by telling our audience a little bit more about Best Formulations and the products that you manufacture?
Yes, thank you. Good morning, everyone. Thank you for that wonderful introduction. Yeah, Best Formulations has been around for over 32 years, and they're really focused on the contract manufacturing, private label of dietary supplements, drug products. So when you see probably 60 to 70% of all the vitamins you see on store shelves generally come through contract manufacturers. So we are here to help them from the beginning formulation all the way to the back end to the packaging. So basically it's a turnkey solution to individuals and companies out in the field who want to bring their product to market. We help them with the formula, help them with the manufacturing, the packaging, and then we send it back to them. Our products, we don't have our own products, obviously, because that would have internal competition, but the products of our customers can be seen in over 26 countries around the world. So it's we've been around in City of Industry for over 30 years and love California, and has been most of our products are seen in U.S., a little bit in Mexico, a little bit in Canada, and of course the Asian market as well.
So Dwayne, while we're here today to talk about plasma treating, you actually were an Enercon customer with a different product, Enercon's induction cap sealers. For those not familiar with that process, can you talk a little bit about what that does for your packaging capabilities?
Exactly. So in our dietary supplements and pharmaceutical, many of our customers ask for best buy or expiration dating on their products. So to qualify that data, we need to create, we look at everything from the vapor transmission and moisture transmission rates through the bottle, basically the stability studies of that. So allow us to quantify that data. When we have an induction cap sealing, we are able to create a hermetic seal on the foil cap onto the bottle, which really drastically eliminates the amount of environmental load that we're putting onto that product in that bottle, because it's essentially sealed. So when we have the best buy of 1 year, we're able to take that to a 2-year, 3-year, if the data supports that. And the hermetic seal is a primary function of improving stability of products for our customers. And the story goes that while following up on one of your induction cap sealer projects, Enercon's local representative became aware of you were having some challenges relative to printing lot codes on the bottle. Can you tell our audience today what your process was like before adding plasma surface treating? Yeah, over the last few years, we noticed much more lot coating on the bottom of the bottle. So as per customer request, we started lot coating with Domino inkjets and Domino Amjet inkjets onto the bottom of the bottle. But a lot of the problems we had, because we source bottles ourselves, also some are customer supplied, but sometimes the ink adhesion rates were horrendous. They would just rub off with your thumb, these would not stick, or they would be adhere properly, and then we would find out maybe a week or a month later that inside the box, as they sit in the bottom of the box, they would rub off. So we had a really issue with the clarity and just the adhesion rate of the ink onto the bottom of the bottle as a big challenge for us. So as we're working, one day Todd Klasick, our local representative, came by just doing a courtesy visit. We're just making small talk, and he mentioned, Dwayne, do you know about plasma treatment, surface treatment? And I had no idea at the time, and holy heck, it was a godsend for us.
Excellent. Now you implemented the plasma treating, and we've got a couple photos here of your option. Can you describe what we're looking at here?
So what you see is the middle photo is a bird's eye view of our bottle diverters. So we have 5 packaging lines, and on the lines we added these bottle diverters. So the role of the diverter is to create a gap for the bottles going through.
In the inkjet technology side, if we have two bottles which are sitting side by side, they may get counted as one bottle and one would not get lot coated. So the bottle diverter there is to create that gap separation. And then on the bottom, you see the plasma treatment flame coming up, and that's where we basically will treat the bottle. And then about 2 inches or so immediately afterwards, we'll apply the bottom of the lot coating. In this case, it's yellow ink. You see some of the overspray there. And that will basically, as we treat the bottle within a tenth of a second, it will immediately get lot coated. So we find the process works for us tremendously well. On the right-hand photo, what you see is how we mount the plasma treatment underneath on the brackets. And so basically, we bracket that in, and it works wonderfully for us. Just thinking of what Jerry mentioned earlier before, I want to this program, I'm just thinking about that. We put ours on a 3-month maintenance program, but now I'm going to reconsider that. Maybe 4 years is the way to go now.
Very good. We've got a brief video we're gonna share here that will just show some bottles being conveyed through, and we're going to start that video right now.
So you see the flame treatment being applied. Well, that's a quick video, and the bottles are going through.
I'll play it again for you.
Yep. So the balls are going through the flame. You can't see that yet. The balls are going through, and then immediately right afterwards, the domino is ink jetting the bottom of the bottle. Incredibly fast process. In the past, we were experiencing before plasma treatment, we were experiencing a 3 to 4% rework rate internally on our process, and we're doing anywhere up to 50,000 bottles a day. So as we install these for this particular rework process, we noticed the rework has dropped down to less than 0.01% internal rework, and most of that is just us our own internal testing procedures. So from a time savings, labor savings, the payback was immediate. It was tremendous, and basically it did not expose a lot of our employees to, as we talked about in the beginning of the presentation, about the buffing them using chemical treatment, those kind of surface treatments we would do internally beforehand. So it was a big help for us, definitely.
Now on this next slide, we can clearly see an improvement in the print adhesion with the plasma treatment. We know that your primary objective was to enable printing on untreated bottles, but you also saw an improvement on bottles that had been treated by the bottle supplier. Can you talk about that?
Exactly. So what we find is, especially with some of our vendors who do flame treat the bottles, as some of you know, that additives sometimes do migrate. So we find a lifespan of 4 to 6 months before we have to retreat the bottles. And before this technology, it was a huge challenge for us. We would have to chemically treat the bottom of the bottles again manually, which is extremely labor intensive. So after we installed these in, retreat them again, one of the serendipity moments we had, we left it on, and on the treated bottles, in this case here, and our untreated bottles, the clarity improved dramatically on the ink. So normally in the past, when we had these concerns, we really looked at the ink itself. We're adding too much makeup to it? Was the ink clarity was an old lot of ink along those lines? But as we added the surface treatment, we noticed an immediate bump in the clarity, as you can see from the photo from the left to the right. And not only was the customer and the consumer happy, it helped us, the quality team was happy, our own individuals are happy, because as we're checking every bottle for proper lot coding and adhesion, it was an immediate payback for us.
Very good results. So in summary, can you comment on your overall experience in adapting this technology to your production capabilities? I know that after the first one worked out for you, you added it to your other lines as well.
Yeah, we started off with one as a trial, and since then I've bought 4 more, so I'm sitting at 5 plasmas right now. And basically the implementation for us, the only thing we needed to get was the bottle diverters, which we did not have on the line prior to that. We added those in, and they literally within an hour of maintenance time, they're installed and they're working, and it works wonderfully for us for the implementation. As for the labor savings, the payback was immediate. Of course, in the beginning, we were a little skeptical and we weren't sure, but it was time and time again, it tested very well for us in all our ink adhesion tests, and the dynes, as we tested using dyne pens, worked favorably for us. So implementation was immediate, the labor savings was immediate, the quality had improved dramatically immediately as well. So it was a tremendous good moment for us. We were happy that Todd stopped by that day, and because at that time we were being very difficult with our bottle vendors and our ink vendors as well. So Enercon came along with a silver bullet for us.
Excellent. Thanks for sharing your insights, Dwayne. Before we get to the questions from our audience, just a review of some of the highlights that we covered today. Plasma surface treating is designed to clean, etch, and functionalize surfaces to improve ink adhesion and print quality. It's effective on a wide range of materials. Plasma treating systems can and should be integrated in line immediately prior to printing operations for best results. And plasma treating enables print adhesion for some applications, and on others it actually improves print results. I can see from some of the comments that we got in relative to videos that some of our audience was able to see the videos without problem. Others could not see them. In the recording of the video, we're actually going to add those video clips in, so if you want to see them, you'll be able to when you access the recorded version. We have a question, are they available, and when can we access the videos? Within 24 hours, you'll get an email from Enercon with access to that. So you can now use the question toolbar to submit any questions to our panel. The first question is for Dwayne relative to printing lot codes on the bottle versus on the labels, and you know, what's the mix? Do you do any printing on labels, and you know, how do your customers prefer that be done?
Yeah, so over the years, traditionally it is the lot code information is placed on the label, but over the last 5-10 years, we noticed a dramatic change where people have switched to lot coding in the bottom of the bottle. The primary reason has been that new products are out there, more innovative products that the customer, I guess our customer, needs to really educate the consumer. So they're adding more and more information on that label. And again, whether it's their backstory to their company, to the product, their proper usage, the nutrition facts and supplemental facts, labeling information has changed. So there's less and less real estate available to them. So the bottom of the lot coding on the bottle has become the primary spot for us to be using. 9 out of 10 bottles for us is lot coding on the bottom of the bottle, where traditionally the number was reversed, not even 5 or 6 years ago.
Thank you for that, Dwayne. Jerry, question for you relative to the parts that were shown were electrical connectors, relatively smooth, flat profile. Is that the typical application for your printing?
Our typical printing areas are flat. We do have some connectors where the area that gets printed is kind of down in a little bit of a valley. The size of the plasma nozzle was nice because it gave us that focused beam of energy to prepare the surface for the printing down inside of that small valley. It was a huge advantage. You know, in the past, when you have to wipe something that's down inside of there, you'd have to break out the Q-tips and the cleaning solution, the methyl ethyl ketone, and in those cases, the cleaning time was much greater than that 5 or 10 seconds that I had talked about earlier.
Ryan, you had mentioned before that plasma systems can be integrated in different configurations. Both of the configurations we saw today were the plasma system was fixed and parts are conveyed under it. What about some of those applications where there might be more contours or recesses that the plasma treatment needs to reach?
Those are applications that will tend to work with an automation partner, an integration company, or just depending on the level of sophistication of the end user, they may have those skills in-house as well. But we'll look at the part and we'll look at what the best method to either convey the part under the plasma or move the plasma around. We've done everything from some very simple automation where the part is moved in a, for a case, a circular motion. We were doing a filter in one case where they were bonding an adhesive to it, and the head itself stayed in a specific position, but the part was rotated underneath the plasma head itself. In other cases, we'll go fully robotic applications. We've used with our flame plasma systems. We've treated the dash panels of an automobile. So they happen to be much bigger surfaces with a significant amount of contour. And in those cases, a robot would be used to not only move across the surface, but then also to accommodate any variation in the depth of the product as well.
Thanks, Ryan. One more question before we conclude the webinar. There's a question here that in both applications there was metal nearby the plasma, and is there any risk of arcing from the plasma treatment?
So the specific technology that we used here is the blown ion style systems. Those can be used in and around both conductive and non-conductive materials. Flame would have the same properties in that you could use it in and around conductive and non-conductive. It really comes to the blown arc style systems where you have to be careful about either a conductive part that you're treating or being around metal around that. So when we get into those applications, we have to be very careful to make sure that not only is the part non-conductive, but that any carriers or conveyors that these parts may be going down, that they're also non-conductive as well. But the reality is, generally what we find is that regardless of the application with both blown ion, blown arc, we also offer what's known as a variable chemistry, which is a variation on the blown arc plasma, or our flame plasma systems, we're able to come up with a solution that solves any challenge that's presented to us. And that's something that does make Enercon unique in that we do present all four of those technologies and options for our potential customers.
Thank you, Ryan. That will conclude today's webinar. We thank you again for joining us, and a special thank you to Jerry Jordan and Dwayne Chrest for sharing their insights with us today. Again, all attendees will receive a link to the recording of this presentation along with access to the slide deck. Thank you again for attending today's webinar.